All right, so extreme values,
What do I get if I say yes?
min or max,
Oh, yeah.
right?
I remember.
Yeah.
Dude, you act like you remember the chapter names.
I thought you might remember to connect the two. We're going to talk about local min or max today.
Oh, okay.
Again?
Okay, so that, if you remember, okay, is this a local or absolute minimum?
Absolutely.
Absolute, correct. Okay. Local or absolute? Local. Local min,
I don't know.
absolute min. We have to distinguish between the two because our analysis techniques differ a little bit. Okay? But it's, the first part of it's not any different. It's in the sign analysis part. So local min or max, we do a sign analysis on the derivative. That's what we're going to do today. Okay? So it's about one step more than you know right now. Right?
Oh, sign.
S-I-G-N.
Yes.
Positive or negative, not here's your sign. Like, never mind. Yes, thank you very much. Thank you, Billing Bull. All right. Okay, so you caught up? Here's the function for that graph, correct? Yeah? In pre-calculus, we just calculated that up and did the minimum on the calculator, right? Here's how you do it in calculus. What is the slope of a tangent line at that minimum?
0.
0. So what do we need to do? Derivative. Okay, what's the derivative? And what do we do with that? Don't plug 0 in. We want the slope to be 0, so we have to set it equal to 0. Yeah, in this case. I'll show you more complicated ones. So x equals 0, right? Okay, we've done that all so far this year, correct? Here's how we know if it's a minimum or a maximum. This is called the sign analysis. S-I-G-N. You will also know this as the first derivative test. Okay, so it's not formally called. To be honest with you, this is not even in your book until it's 4.3, but it's easy to take. It's easier to take care of it now. So this is actually the word from 4.3, but we're just doing it now. All right. So 0 is my value that I've figured out, right? So what's f prime at -1? Negative, right? So I only have to worry about the sign. That's what's neat about this. I don't have to worry about the number. You can put the number if you want, but what's f prime at 1? Positive. Right. So what does this mean? The slope is negative. Slope is, we have a local minimum. It's a local min at x equals 0. So we can do all that without even looking at the graph, right? And the derivative tells us whether we have a max or a min. We're getting that.
How do you know the local minimum?
This is because we don't know. On this one we know, right? But how about this one? All we've done is analyze right here. We don't know if there's something below it out here or above it out here. So all we can say with the first derivative test is that this is a local minimum
Okay.
absolute minimum would require some restrictions, and I'll teach you that tomorrow. So just rest in the fact that you can do this, right? Okay. So if you're describing this on a free response, you would say f of x has, okay, do not put it, you will get it wrong. You're losing a point if you put it. F of x has, oh gosh, that is ugly. A local minimum at x equals 0 because f prime of x changes from negative to positive. It'll be a max. Yeah. Okay, so what you're looking at here for your x, you will have every one of these problems on a free response will have explain or justify. You need to identify f of x, local minimum at x equals 0, and the because. Okay. There's different ways to say all that information, but
The identification, the answer, and the why.
identification, location, yeah, answer,
Yeah.
yeah, and why. Yeah. Okay, let's try a harder derivative here. I know, right? Oh, yeah. Okay, let's try this function.
Alrighty.
So if we're trying to find the extrema, first step is derive, okay, which is
3x squared minus 18x plus
and what? Yes, that equals 0. Now, can I factor a 3 out?
Yeah.
You can. So why don't you do that? Greatest common factor is a great thing because it makes things easy. Now this is where pre-calculus comes into play. Algebra. So are you okay with that factored 3, everybody? Okay, can I factor that equation?
X minus 4.
Right.
Before
You with me there? Should be. What are my zeros then? 2 and 4. Okay, those are our critical points. Remember that word?
we have to check anything too.
Now we do our sign analysis. So pick easy numbers. Okay, I'm going to slow down so you can catch up. Because I tend to blow through these.
How did you get the x squared 6x plus 8?
I factored a 3 out.
Okay.
Divide by 3. Greatest common factor. If you can do it, do it. I would pick f prime at 0. If you can, pick 0. Then pick 3 because it's the only whole number, and then 5 works. It's easiest to use this one. Okay, 0. If I plug 0 in, negative times a negative, right? If I plug 3 in, I get a negative and a. If I plug 5 in, positives. Yeah, So use the factored form if you can, because it is easier. Same answer as above, it's just easier. So what do we have at 2? Positive to negative slope, local max. And here we have negative to positive, local min.
So then, when you write that out, you say f of x has a local min at x equals 2, or, yeah. a
Local
max
min.
At x equals 4, and a local max at x equals 2 because.
You have to separate the because.
Um,
F of x has a local min at x equals 4 because f prime goes from
negative to positive.
and,
Has a local max at 2 because it goes from positive to negative.
not it,
Oh, f of x goes.
f prime
That's probably.
that goes from positive to negative. You do not use that word in here, it. Unless I'm referring to a clown. Okay?
Even if you're doing that, stop. I hate clowns.
Me-
Hate.
Okay?
Get with shotgun, kill dead, hate that.
So
Huh?
get those statements specific. You want me to write that down?
One.
Yes.
So
Hopefully not one,
f has a local max at x equals 2 because f prime changes from positive to negative. Okay, you can get that symbolic. And then you can write the same statement about the minimum. Okay. But look, can you tell the shape of that cubic?
Yeah.
Yep. You could talk about end behavior. How about concavity?
Yeah.
Concave down, right? Concave up. I mean, you start to see some of the ways by hand we can graph these. Okay. All right, we don't have any time left,
Yeah.
so yay. This is 4.2. Prelim number 1, exercises 3, 4, 7, 9, 13, okay. If you want, you can start this. Right there. We'll score that tomorrow. Don't worry about doing the APs till tonight, but the rest of it for sure. Thanks for your time today. So you learned something. Yeah, do that tonight. You can wait on this. We won't score this for 2 days, but that is due tomorrow.
Oh, okay.
1 and 5. So 10 problems. All derivatives like these.
And that's due tomorrow.
Yes.
Okay, Anderson.
See you later.